Hello everyone, welcome to another video. This is optimized water distribution in a village. It's a Leetcode problem, which is premium, right? A premium Leetcode problem. I'm asked by Google, Facebook, and Microsoft. So I hope you guys, get a lot of utility from this video. Um, there are basically we have instead of like going deep and reading the question, let me just like try and explain it. Basically, we have a number of nodes, right? Um, that represents houses. And there are houses in a village, and then we have been given a cost array, which is pipes, which shows you the connection between any two houses is a bidirectional connection, and then it gives you the weight. Right, the weight is the third element in the in the array, right? And basically, you've also been given another cost array called wells, where wells is showing you the cost of building a well at any house, right? Um, and then the question is asking you to return the total cost to supply water to all houses. So you've been given a graph, and then you're supposed to connect it such that it connects to every house, right? And then you supply water to every house. So the question is, how are we going to solve this? And if the previous explanation or what I was saying about connecting the main course, connecting different nodes, rings a bell, then you know that we are going to use Kruskal's algorithm, right? So in short, Kruskal's algorithm is a use of the union find method, right? Where nodes that haven't been previously connected can get connected, and once they are connected they will have the same parent, right? And if they have the same parent, then any subsequent connection that wants to use make those kind of connections redundant is not going to be allowed. So to even be able to solve this question, you should probably look at redundant connection, right? One of the more popular legal questions, and also look at the main cost of connecting houses. It's also a specialized legal question where you both use the union find method. So by using a union find, right, we can create a minimum spanning tree which connects every house, MST, connects every house. And then now the question is, how are we going to approach it with the wells? Because we also have to have at least one house connected to a well, right? So that it can supply water to everyone. Well, we can still have this as an MST problem if we create an imaginary node called node zero, and then use the well, like we connect the node zero to all the nodes, right? So connect it to node one, node two, node three here, right? And then after connecting them, we choose the one with the least weight, right? We'll be using Kruskal's algorithm. Choose the one with the least weight, and then its weight will be the cost of building what the house. Sorry, building the well in that house that is connected to, right? So that's how we are going to approach the problem. And I just want to demonstrate it using on a whiteboard. Right. So basically, we are just going to look at the one from the question one, right? Where we have the edges, and as I was explaining, right, we want to have an imaginary node like this, zero, and then basically with the minimum spanning tree is going to connect to one of these nodes. But I'm going to choose the one with the least weight. So here we have the one with the least weight being one. So what's it connecting to one as well as a cost one. So in the end, you add this, and this. These three cost each of one, and you get the total cost, the minimum total cost. So I'm going to make a minimum spanning tree. So how are we going to build a minimum spanning tree? As I was saying, that like you make a node, so like zero connected to what every single node. So you have zero connected to one, and then what's the cost of that is what one, right? Which is the cost of building the water source at one, right? So one, again from zero to node two, what's the cost? The cost is two, and then from zero to node three, the cost is also what two. And then all the nodes we also have in here, right? We have one to two. The cost is what one, and then we have a two to three. And the cost is what one. So by Kruskal's algorithm, right, we'll initially sort the edges, all the edges we have by their weights, right? So the minimum weight ones will be there first, and then we connect them like based on the ones with the minimum weight. So the ones with the minimum weight here are what 0, 1, 1, 2, and 2, 3, right? So um in the end we pick the first one, which was 0, 1, 0 and 1. Once then our union find method, we've connected them by this, they have the same parents, right? So a connection like 0, 2 would not be valid because like it would not be valid at the time that I want to use that, right? So let's first go through the edges that we are interested in. So 0, 1, cost 1, um, 1, 2, cost 1 again, right? And then 2, 3 also has a cost 1, right? So in the end, we've actually even met all the nodes, right? We've certified node 1, node 2, and node 3, and our new imaginary node 0, right? We've reached the n plus 1 nodes. So we've actually processed everything, and then we just return our main cost. But let's say that this 0 and 2 was what 1, the edge was 1, and then we had previously made this connection. We made a connection with 2 and 1 in the same group, 1 and 0 in the same group, and now we have this and want to connect 0 and 2. We wouldn't be allowed to do that because our union find method is going to detect that they are already in the same group. So if it's in the same group, that connection is redundant. So I'm not going to use that. It's not going to appear in our minimum spanning tree. So basically, this is our MST. And without further ado, let's get into the coding. I don't really have a preference between what I usually do, which is like whether I use the dark mode or the light mode. I think the light mode is easier for the demonstrations. But first, we want a priority queue. And it's going to take an edge, right? And so we call it PQ, a new priority queue, where if we have two elements A, B, and we're going to create those class by A dot cost is going to use and then B dot cost, right? Okay, so basically what I want to do first is create and let me list them in steps, right? So that it makes sense. First, we want to create an edge class. Second, I want to create a union find class, and then use sort by weights. I think I've already started by doing that with a priority queue, and then build our MST for our minimum spanning tree. So basically, this, and let me just follow the rest, and then we'll get back to this function, which is for main cost to supply water. So our class of edge, right? Which argument is it taking? Basically, it's going to take the source node, right? So U is going to take V, and it's going to take the cost, right? So public edge, this is how I want to in V, and then the cost. Alright, so this the U is equal to U, and this the V is equal to V, and this the cost is equal to cost, right? So now we're done with that part, and then we also want to create a class of union find. Okay, so in the union find we'll have parents, right? And every node will initially be its own parent. You have rank, and then public find. We'll take an int n, and then our parent array will be an int array of what n, size n, and then rank also will be an int array of size n, right? And then basically I want to set each parent to itself actually, right? So yeah, parent, let me just use n, right? And k plus plus. So parent k is set to k, and parent and rank k is set to 1 initially. Right, so have an int method where we return the parents, right? So while I is not equal to parent I, we do some path compression. So parent I is equal to parent of parent I, right? Parent of parent, you see where I'm going, and then I is set to parent I, and when this while loop is done executing, we return our I, right? Um, and then we have a boolean function where I'll use it to connect two nodes. So when I'm connecting two nodes, I want to check first who their parents are, and if their parents are the same, right, then we know that there's already connected. So if root a is equal, root a is equal to root b, right, then I'll return false, right? Why? Because they are already connected. Else, we want to then assign it based on rank, assign roots based on rank. So say if the rank of root A is greater than the rank of root B, then root B's parent now becomes root A. Right? Root B's parent becomes root A, so parent root B is equal to root A, and then the rank of root A increases by the rank of root B. Else, do the opposite, root A set to root B, and then the rank of root B is increased by the rank of root A. Okay, so once that is done, we return true. Right, we've connected the components successfully. They weren't already connected. So that's done. Create edge class, create union find class, and now we want to sort by weight, right? So that's what we're initially doing here, where we created a priority queue which takes edge, right? And, and then it sorts the edges by the cost or the weight, right? So that said, I want to also create a union find object. Right, this is what we'll be using to make our MST. And it's going to be n plus 1. Why? Because of that zero edge that we created, right? So it's going to be up to n plus 1. Right, cool. And I also need our main cost, right? That's the cost of making a spanning tree, and then the number of nodes that we've processed. So if the number of nodes we process, we want to, when we process n plus 1 nodes, then we stop working on it. So basically, we want to fill our PQ first, right? So in filling our PQ, we're going to create those new edges which connect the 0th node to each of these nodes. So say for it's k is equal to 1 and k is less than n plus 1, right? And then k plus plus. Then I want to create a new edge. So call it edge new edge. A new edge is equal to it's going to start from the source node rate 0, and then it's going to go to it's going to go to k, right? And then it's going to use wells k minus 1, right? And the question even rightly says so. For each house, we can either build a well inside with a directly with the cost wells I minus 1, right? I minus 1. Okay, cool. So k minus 1, we are done building the well, and then we add that to our priority queue, right? Else, we want to go through pipe and add every edge in pipe to our priority queue, right? So see again, a new edge is being created. A new edge is equal to our pipe is 0, right? The pipe 1, right, which is the source and the destination, but it's bidirectional, and then the cost, right, which is pipe 2. So then the PQ will add new edge basically. Okay, cool. So we filled our PQ. Now it's I think what we want to do is to go through every element in our PQ. Now our PQ is sorting by what? We're gonna sort um by the edge weight, right? So whilst our PQ is not empty and by the number of nodes we've processed is less than n plus one. If it is less than n plus one, then we are good to go. So then we take the current edge that we have. So say edge current, which is what the PQ dot pull. Right? I'm going to pull, and then I want to say int I is equal to our current dot u, right? And then int j is equal to our current dot v, and then int let me see, let me call it w, right? This is our current dot cost, right? So we'll have a boolean, and I want to call it unite, right? So basically it's going to take the union find object we have and then have a make a union between I and j, right? Now basically if the it's already been connected, it's going to return false. But if it's not being connected, it's now being connected, it's going to return true. So basically, based on the value of unite, we can add to our main cost or not. So if unite, right, that means we just added them there. Now it's now a new connection. What I want to do is increase the number of nodes we've processed, right? To increase process by one, and then the cost is going to be sorry, it's called main cost, right? The main cost is going to be increased by what the cost here, which is what W, right? So then once this is done executing, we are done, either condition, whether the priority queue becomes empty or, we hit the number of nodes, total nodes being processed, right? Once we are done with that, we want to return our main cost. So that should be it. It passes first two tests successfully, and then right beats 70 something percent. So that's good enough. Okay, so now the question is what's the runtime, right? That's a good question to ask. Now, and let's go through this together. Basically, we look through each edge, right? So n edges we create for each edge, but we are creating them here. So n of n operations here, o of n operations here, right? And then o of n operations here. Basically, for each edge, we're going to check if what we can add it to our union find method. Now, our union find method, right? This class is going to have a whole runtime of what alpha. Whatever alpha is, I think alpha is like almost constant, right? So it is n times alpha. That'll be your runtime overall, and that should be it, guys. I You feel free to look at the code in the description below. Like and subscribe. See you on the next one. See you guys. See you. Bye.